Hello, welcome to this concluding session for the course Database Management Systems. We know that this course, that is Database Management Systems, is a very important course for any program offered at undergraduate level related to IT, computer science and information systems. Let us have a look at the topics we have covered in this course. We started with introduction and overview of the database management systems and advantages of the database management systems over the file systems. We discussed the 3 schema architecture of the DBMS, the result, that is data independence, which is the result of this 3 schema architecture and which is a very important advantage of the DBMS. Then we have seen the structure, architecture of the database management system, the various modules and their activities or the functionality. Then we have seen the various users who use the database management systems with the different intentions. Next, we moved on to conceptual database design, where we have used the ER modeling for designing the database at very high level. And in this, the concepts or the constructs we are using are more or less same as what a end user can understand. We try to describe the database in terms of entities, properties and the relationship between the entities. We have seen various notions in ER modeling and the notations, that is the symbols used in ER modeling. We have also captured how to model the class hierarchies in ER diagrams. Then we discussed about various important features of relational data model, which is the subject of this particular course. In this course, we try to understand all the database management systems related concepts in the context of relational data model. We have seen relations, tuples, keys, integrity constraints, foreign key constraints, so on and so forth. Then we have conceptual design in terms of ER modeling and we have relational data model. We discussed about how to map the ER diagram to relational schemas, mapping entities, mapping weak entities, mapping relations, constraints and how to map class hierarchies that have been captured in ER model to relational schemas, that also we have discussed. The next discussion was about the relational algebra and calculus, which are the formal query languages for relational data model. We have seen relational operators, set theoretic operators, the very important and then useful operation, that is join operators and various kinds of join operations, left outer join, right outer join, full outer join, all these things we discussed. And then we have seen very useful function, that is the grouping operation, and which can be used in conjunction with the aggregate operations like sum, min, max, so on and so forth. We started discussing about the SQL 99, which is the latest, the current standard for SQL specification, as part of which we discuss the data definition language statements, using which we can define the structure of the database and we can drop certain structures, we can alter the structure of the database. Then we looked into the DML commands. The popular one is the select from where class, which is used to retrieve data from the databases. We have also seen how to delete tuples, how to modify the tuples in a database. Then we have seen the concept of views, very important in database systems which are provided by this SQL. View is a virtual table which contains data from various other actual tables which are part of the database. We have seen how to define views and what are the various characteristics of views, that we have seen. Then we took up database design related issues. Functional dependencies. The database design heavily uses the concepts like functional dependencies and keys. We have seen what are functional dependencies, what are the various inference rules. We have IR1 to IR6, out of which IR1, 2, 3 are called as the Armstrong inference rules, which are heavily used in finding the closure of a functional dependency set, and functional dependencies are the concepts which are heavily used at the time of database design or data refinement. Then we moved on to database design and normal forms. We clearly understood what are the rules or conditions for various normal forms, that is first NF, second NF, 3NF, BCNF. And then we had a brief idea about the fourth NF and fifth NF. We had detailed discussion and examples for second NF, 3NF and BCNF. Then we talked about the decomposition, which is a very important activity that is taken up at the time of schema refinement. That is, when a given relation is not at a given normal form, if we want to take it to the next level highest normal form, then we will resort to decomposition, wherein we will split the original relation into sub relations. And at the time of decomposition, we will take the database to the next normal form, but at the same time we need to be careful about certain properties, that is lossless join property and dependency preserving decomposition property. These two are very important. Any decomposition must satisfy these properties. And dependency preserving decomposition is very important, because all dependencies in your database are going to represent some business rules. If you are losing some dependency, you are losing a business rule. If you are adding some new dependency, you are unnecessarily adding a new business logic, which is not desirable. So we need to be very careful about these two properties at the time of decomposition. And we have also seen, when a decomposition is given, how to check whether it is lossless or not, whether it is dependency preserving or not. We have seen certain techniques, algorithms. We started discussing about storage and file structures. We clearly understood what is the basic structure of a disk storage, that is disk pack, and a disk pack contains disk contains surfaces, surfaces contain tracks, tracks contain data blocks, actually where the data is stored. And then we have seen the file and record organizations, and actually all the data is contained in files only. A file may contain more than one data block. For every relation in relational database, we have a file to capture or store the data related to that particular relation. And we have seen record organizations. We have unspanned record organization and spanned record organization. Then we started discussing about the hashing, which is a very important technique for fast retrieval of the records from the database. We have seen internal hashing, and we discussed a important phenomena, that is collision, and how to resolve such kind of situation. When more than one record is hashed onto the same location, it is called as collision, and we have seen looked at various mechanisms or approaches to resolve collision. And one important collision resolution mechanism is chaining. Then we discussed about static and dynamic internal hashing. Then static and dynamic external hashing is also discussed. In static hashing, the address space is fixed. Additional buckets cannot be added to the address space, and if there is any collision, we need to resort to chaining. Too much of chaining again degrades the performance, and the purpose is not served. Hence the dynamic hashing has been introduced for this external hashing. Internal hashing is used for files on the RAM, whereas external hashing is used for files on the disk. In dynamic hashing, the files can grow or shrink depending on the requirement, still the performance will not degrade. Under this dynamic hashing, we have seen the linear hashing and extendable hashing. Extendable hashing is going to use a directory structure, wherein the linear hashing technique is using multiple hash functions. We have seen how these techniques work, what is the basic mechanism for these hashing approaches, we have seen in detail. We started discussing about indexing. We have seen what is primary index, secondary index. Like hashing technique, indexing technique is also there for fast retrieval of the records from the database. We have seen what is sparse indexing, what is dense indexing, what is multi-level indexing, and we have seen what is a B+tree indexing. With sufficient examples, we tried to understand the basic concepts related to indexing for various indexing mechanisms. Then we started discussing about the transaction model, which is a very important concept for database management systems, using which we are going to maintain the atomicity and which helps in recovering from the crashes without leaving the database in some inconsistent state. We have seen what are the advantages of having transaction model. We could understand what is the life cycle, that is what are the various states of a transaction which has active, partially committed, committed, failed and terminated states. We have seen what is a transaction schedule. A schedule may involve more than one transaction, and it is going to give you the details about what is the sequence of operations that belong to various transactions or executed, that is given by a schedule, or it is also called as a transaction history. Then when you have multiple transactions concurrently executed, what are the disadvantages and what are the advantages? Concurrent execution of transactions will increase the throughput. At the same time, that may lead to inconsistency, because the multiple transactions are trying to access the same data items, which is very dangerous. Then we have seen the concepts related to the serial and serializable schedules, and we have seen what is conflict serializability. And a schedule is serializable, that is a concurrent schedule where the instructions of multiple transactions are being executed in an interlude fashion. If it is serializable, then it is very desirable to have such kind of serializable schedules, because I am going to enjoy the throughput. At the same time, there won't be any problem with respect to consistency. Then when multiple transactions are being executed concurrently, and then when they try to access the data item simultaneously, to avoid problems, to achieve serializability, what control mechanisms can be applied? We have seen the mechanisms based on locks, and we have seen the mechanisms based on timestamps, and we could understand what is a deadlock situation and how a deadlock situation can be detected in a given schedule. With ample examples, we could understand these concepts. Finally, we talked about the database recovery. When there is a crash, system crash or some failure during the execution of a transaction, how to recover from that, because a transaction, when it is under execution, may leave the database in an inconsistent state. Hence, when a transaction fails in between, we need to make sure that that state of the database should be taken back to the previous consistent state and then restart the transaction. We have seen various mechanisms which will facilitate this recovery. The first technique is log based recovery, where we have deferred modification and immediate modification techniques, and which are going to use the log entries. And then we have seen a very important notion called as checkpointing, which is going to reduce the overhead due to redoing the operations or the transactions at the time of failure, on detecting a failure. Then we have seen another database recovery mechanism, that is shadow paging, and we have seen some examples to understand all these concepts. And this particular course has given us ample sufficient understanding about the various concepts related to database technologies, and now we are equipped with knowledge to model a database, design a database and implement a database for required applications. Now I thank you very much and I wish you good luck.